Whenever you open robot, there will be on the left new or open project. So if you press new, you'll have this window. Robot will ask you, do you want to design reinforced concrete buildings, steel buildings, tanks, 3D trusses buildings, slabs or surfacing elements or plates design, 2D framing system, 3D just grilled systems, it has many things. This is for separated reinforced concrete elements. If you want to design just a beam or just a column or. This one is for steel connections, section analysis, and then. So we're going to take any of them will be good with us. Now, what are the two differences between those two? In this one, you can use steel sections, but in this one there is seismic analysis. While in this one, if you're going to design only a hole or a hangar, in here there will be no seismic actions and no concrete at all. But in here there is concrete. So if you want to design a big steel building, then you have to take this one, a building design, even if it's concrete. I'm going to take this one, a 2D frame analysis, because I don't need a third dimension. I'm working in 2D. So I'll press on frame 2D design. It will take a long time. This is the main window of the Deer robot. On the top, you have the modifications and the definitions. If you want to define a new material, you want to define anything, it's on the top. On the right, there are the drawing and the design orders. If you want to draw a beam, if you want to draw a slab, it's on the right. The very first thing you have to do in any structural program you're going to use is to choose your units and to choose your standard that you're going to use. We're going to use the Eurocode, so I have to assign that. We're going to use millimeters, meters, we have to assign that. So in robot, to do that, you go to tools, first to preferences, because in preferences you choose your colors, your languages. It has Hungarian, if some of you is interested. I think it has Latin you speak Portuguese, right? Yeah, so I think it has Portuguese working language. Let's see. Espanol, I think it will work for you. I don't know. So we'll keep it on English. I like those colors. Now, tools, job preferences is to assign your codes or your standard. You go to job preferences. Now, units and formats. If you open this one, you assign for your dimensions, your forces, your everything else you want to. Your materials. What code do you want to use at the beginning? The Eurocode. What is your material as a default material that you want me to use? You can change it later, of course, but this is the default one. So this one is for steel, for concrete, for aluminium, and for timber. And I know you love timber very much. Database is how to design steel for you. Where to get my sections from. This is the Eurocode. So in here I have the Eurocode. Then it knows now the HEV section, the IPE, the. If you assign an American section and to add a new code, you press on this star. You choose Isaac, for example, and in Isaac, the American Institution for Steel Construction, it has different labels for sections. W something, C something, blah, blah, blah. So we're going to use the Euro one. Vehicle loads, it's going to be by the Eurocode 1. The bolts by the ISO, which is related to the Eurocode 8. Design loads, the steel will be designed by EN 1993. The steel connections will be 93A18, the timber, the RSA, and the geotechnical. And I know that you love geotechnical as well. Where do I get my loads from? Those Eurocodes. So everything is set for the Eurocode now. And at the end, you can save it as default. From here, save to job preferences and save as default. So this is my default parameters always. After doing this, you're done. You can start your procedure. So to draw a beam, first you have to define those dimensions for the robot. Those 2, 10, 5, 3, 1, and they are by drawing this grid system. These lines, A, B, C, D. So since we need only a 2-dimensional, then we have to draw an axis to here, only a single one, which is going to be this line, and we have to draw a line here, the line here, and the line here, and the line here, and the line here, and the line here. Okay? So the drawing of the grid is from here. Axis definition. Oh, you can see everything. That's it. You should have told me. There you are. So this is the axis definition. These are the orders for the drawing or for the design. This is design of steel, design of connections, design of timber, design of concrete. I want to draw the axes. I'll press on this one, axis definition. Look at it, it's only X and Z. There is no Y because we are in a 2-dimension. So on X, we need a 0 axis and then we'll go. In here, we will ask you, where do you want to start from? How many times do you want me to repeat this distance? And this distance is how much? So at the beginning, we're only zeros, everything in zeros, the very first point in there. The second one is going to be a single repeated with this distance of how much? You tell me. 2 meters. And the next one, now it will tell you, look at the screen, you are now on the 2 meters. So be careful of the second step. In ETABS, it's not like this. You do it by orientation or by distances. So in here, you can do both of them. So since you are in the second, you have to give it 10 now. Or you can press here 0 and 12. Exactly. So 10. The next one is
5.
5. The next one 3. The next one 1. And on the Z, we need only a single line, which is the 0 line. And I will name it by its value of the level, while on X, I'll name it by 1, 2, 3. I'll press apply. You don't have to care about it. Because I'm standing here. If I want to draw a new line. So this is the main grid that we're going to work for. This is if you want to draw a usual grid system. If you want to draw a cylindrical one, you go to here, and if you want to draw an arbitrary one, you go to here. You'll face that in your life. So this is the main one that we're going to use. I think Hazim is right, because this seems like 2. Yes, it is 2. Thank you, Hazim. So it's a complete of 1 and apply. Now this is a 1. Save the work. Always save the work. Not save it on desktop. You can do the saving by the Ctrl S if you don't know. Just Ctrl S, Ctrl S. Ctrl S is saving. Now I want to draw the beam. Since our section is HEB 340, I need that section. I'll go to draw a bar. It will give me, do you want it a simple bar, a beam, a column, whatever. Those things, I don't care about them now. They are a design related thing. So you can draw whatever you want to now. What is the section that you want? I see nothing in here. If you want to define a section, you press on those 3 points. It will open a new window for you, a new section. It's going to be a steel section. S355 is the material in our project. The design is the database is from the Eurocode. I want an I-shaped section from the family of HEB, the section HEB 340. And add, it will be now drawing by it. And now I'll draw the first span, which is from here to here. And then, if I press drag, it will keep drawing continuously. So you can turn off the drag and redraw it from here to here. And then from here to here. And if I press the drag, I can continue drawing continuously. Those are the main spans of me. If I want to see the shape of it really, I'll press on this one, section shapes. Press on it and press this 3D one. You can see the section of you. This is the HEB 340. Now you might ask me, don't we need to draw this B effective? Don't we need to draw the concrete above it? Now not. Because I'm only finding the applied moments, so I will assign the loads only. Okay? So we'll back to the front view, or to which is XZ view. Now I have to assign the supports. Simple support, simple. So I'll choose those points, and in every structural program, if you open your mouse from the right to the left, like this one, I'm in the right, going to the left, it will choose and select everything that is touching the line. But if you open it from the left to the right, it will select only the thing that is fully inside the grid. So now I want this joint and this joint, this joint, and this joint, and this joint. And to assign a restraint, it's in here. Supports, it's going to be a pin, supports, and apply. And there is it. This is exactly the shape of our beam. I'm going to save it again now, and now I'm going to define the loads. Loads, load types. The first load I want to assign is a dead load. Every structural program includes the self-weight inside the very first load you define. Let's say it again. This is the first load that you're assigning, the very first dead load. Then the self-weight of your whole structure will be automatically included in it. So that means now when I'm assigning the load, I don't have to define this load. I'm not going to assign it because it's calculated automatically. That's why I like to call it dead W, dead weights, and the nature of it is dead, and the subnature is structural. Structural because it's a beam. Non-structural is an architectural wall. This one is. It's the same, yes, included in every structural program. If you're going to design something for seismic, take it as an advice. Define a load that is called self-weight and define a load that is called dead loads. It's for seismic actions, that's preferable. But in this case, we can use only dead weights. Then add. The second load is going to be a live load. I'll call it live, and live. And for those of offices, was it category what? B, C, do you know? C. You can choose its category C. You can don't choose any category. If you are defining your combinations by yourself. This category, because now you will see we will define the load combinations. You can just check automatic combinations. So it can take the combinations automatically. You have to define nothing. 1.35 plus 1.5 plus. You don't have to define it. It can do it automatically. But you have to be careful for choosing this category. Because if you were a category H, if you've chosen category A, then what is called psi, I, will be different between the loads. Usually I define the combinations by myself. I hate the automatic one. So this is the live loads. Close and save. Now I want to assign a rectangle of dead loads on the second span on here. So I'll choose this bar. I'll assign the load by here, load definition. I'll go to a bar. Now look at the case, it's a live load. How do I assign? Am I now assigning a dead or a live? It's by where are you standing here. I stand on dead load, then it's dead weight. I stand on LL, then it's live load. So first I want the dead one. Dead weights, and I want it a uniform distributed load. Then I press on this one, and then where is it? Is it towards X? Is it towards Z? Is it global or local? You know what is a global coordinate system and a local coordinate system or not? We are now working in the global coordinate system. Those are the axes of the global local system. But if you want to see the locals, there are they. You can turn them on from here. Local systems. I'll turn them off. Now I can keep it global, and for that beam, and the value is on Z, not on X, because this is Z. We're working vertically. So it's towards Z. And how much is the value per kilonewton per meter? Negative 12. Perfect. You have to be careful of that, because in ETAPS, it has what is called gravity. So it's already, so it has a negative already, so be careful. In ETAPS, if you added negative 12, it will be negative, then positively it will go to the other. So ETAPS is a different thing. So 12, add, and apply. Now I want to draw the live load rectangle on the same beam, then I'll go here, and once again, how much is the value? 36? 6. Mine, yes. And that is it. Now I'll go to the other one, to here, to this span. And I need a triangle of dead loads. I'll go to dead weights and I'll choose this one. Trapezoidal load. I want it towards Z. And how will be the values? X, the first X is how far is the P1 from the beginning of the span. Why 0?
Because the half from the first.
It has to be the half because the maximum value of the triangle is in the middle. And in here you can add the values relatively or absolutely. So relatively will be good because it's the half. And the end will be x2, the end of it, it's the end of the beam. The P1 is how much? Minus 36, and the P2 is 0. If I press apply, it will just look like this. Let me make sure that the x0, this one should be 0. Should be 0, and this one will be minus. Same shit. This is what I've forgotten. So in here you can choose if your road is by 2 points or 3 points or 4 points. Ours is by 3 points. Now we go back. The P0 is 0. The P2 is in the half and it's minus 36, and in here it's 0. So add and now apply. Once again, for the live loads, and in here, no, in here, and the 3 point, how much is it?
18.
And apply. Now to see all my loads, I can stand on the load I want. So let's stand on the dead loads. I turn off the section shapes, and in here you have the load symbols and you have the load values. So now you in here have 36. And in here you have 12. Is it correct for the dead loads?
Yeah.
And for the live loads, you have 18 and you have 6.
Yeah.
So we're turning them off again. Now I'll define the load combinations. I'll go to loads, manual combinations. I like to label the ULS combinations by 101 and the SLS by 200 and then. So I'll start with ULS 101, and it's going to be 135 DL plus 1.5 LL. Isn't it okay? Then okay, then now this load, please factor it by 1.35 and take it to the right, and then this load, factor it by 1.5 and take it to the right and apply. Now this combination is defined. Now we'll define the other combination. New, it's going to be SLS, and it's going to be numbered by 201, and it's just dead load plus live load. Those two together, factor them by 1 and take them to the right and apply. Okay? Close and save. Now let's see what do we have in the loads list. We have dead loads or dead weights, live load, the first combination and the second combination.
Do we have to do with a degree of freedom or this?
No, nothing. You have just to draw this shit. Nothing at all. Now you can press the calculation, the analysis. I'll press on calculations and wait for a while. It's very easy in such a case, but you have to design a building, you have to go a little bit deeper in detail. But if you got this, have you seen what we've done? We've drawn axes, we've drawn the beam, chosen a section, and assigned some supports, assigned the load, and now press analysis. This is the fundamental thing for every structural program. Every structural program works like this. You have to find, okay, where is the axis? Oh, there's, okay, a support, yes, that's it. So this is how you can learn by yourself. Okay? Now, the lock in here is locked. This one. And look at the bottom, results are green. It means now you have finished your analysis and I can show you results. If I've modified anything, this light will turn to white or to red. You can't use your results anymore. You have to do the calculation again. So to see the results, I'll turn off this one and I'll go to results, diagram for bars. you can see the axial forces or the bending moments on Y, the deformations, the stresses, the reactions, the reinforcement in case if it was concrete, the parameters. What does a parameter mean? It means how to show you the diagram. A field diagram or a whatever diagram, and then determine and then determine. So I prefer labels and different colors and the field diagram. And well, let's see it for MY and apply. So this is a bending moment diagram, but for what load? If you look up there, it tells you from all of the loads. That means it's the minimax, exactly. This is the minimax diagram for the bending moment. If I want to see it from the 1.35, that is from the first factor, then this is the bending moment of it. In the moment in here is 195, in here is 136.75, in here 205.31, blah, 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 blah. So you can see that because of the very high negative moment in here there is almost no moments. In your future life, as an engineering look, I tell you why, because this cantilever is very short, it's just a meter. So if it's very short, you can neglect it. But of course you can't. But I mean in your mind, you can determine why is this value. So this is the shape of the bending moment. Now the scale will be the scale will be changed. Go back a little and press normalize. Go back and normalize. However you go, you press normalize. The scale will be changing. Okay, I don't want the MY, I want the FZ, which is the shear diagram connection, and apply, and this is the shear diagram connection. Have you ever seen this shape for a shear? Because it's a triangle load. And this is a second order shear diagram, because we have a triangle load in here. So this is why it's not drawn by hand, because you don't know the real equation for this curve. So these are the moment diagram and the shear diagram from this, and now this is from the serviceability. What do we need from the serviceability? Deformations, and we go to the deformations, and in here, let's turn off the FZ and apply. So this is the deformations diagram, which is almost zero in there, and if we've pressed local extremes all, apply, it's almost a zero. It has given you no values. I am surprised. I'll make sure of that again. Let's go back to deformations. Yeah, there could be a problem. I have to check it later. So from the combinations, let's see. What do we have here? No, the moment the section is huge, there could be a no deformation.
Yeah.
So let's see, are the values correct? They are correct. Now if you open or not open, I'll open it here. Let's go to the beam. This is the beam that we've got. This is 136, and this is 136. This is 195, this is 195.61. So this is where I've drawn those diagrams for you. So now, since we've got those diagrams, what do we else need? The reactions. How to find the reactions? Let's turn off the binding, the moment. Let's go to reactions, choose FZ and description to show you the values. Go back and normalize, and these are the reaction. In here, the reaction, look at it, it's from the top to the bottom. It's a -1. And in here, this is the values. Why do we need those reactions? We need them when we're going to get the values to the columns. Because those two reactions will be distributed to the column. Okay? So I'll save the work now. And since we still don't have a lot of time, I'll do another practice by doing the other beams moment diagram. So I'll save this one. Okay, it's structure 1. I'll go to open a new file. A 2D. And the other beam was like this. Where are you? There you are. This is the other beam. We have concentrated loads that I have to explain it to you. Do you have minds or you're dead?
Yeah.